So hello everyone and welcome to this webinar. I'm Laszlo Virag, as CTO of Commsignia. We are here today to provide an essential knowledge of different network technologies such as 5G, LTE, CV2X or cellular V2X, and cloud, and showcase how you can combine these technologies now to build robust and reliable road safety services. I talk about the evolution of CV2X, what we can use now, and what's ahead of us in the coming years. The current administration plans to upgrade and improve the infrastructure, and cities and road operators hopefully will see new opportunities, and they will want to spend their money in the best possible way. So we would like to help you in making good decisions when it comes to digital road infrastructure. When we talk about road digitalization, the general goal is saving lives, and you will see that not all technologies serve the same purpose. Another problem is that terms are often used loosely. Some consider CV2X is the same as the 5G we use in our phones. And it sounds like a tempting promise to use the phones to save lives on the roads, isn't it? Hopefully by the time we arrive to the Q&A section, we will know if and how we can use our phones to save lives. Road users have an amazing variety of devices, such as cars, bikes, e-bikes, e-scooters, and even pedestrians are equipped with high-tech gear. Everyone has a phone in the pocket, right? Sounds good, as we want to make roads safe for everyone. And there is also an amazing variety of radio technologies and channels. We have the 5.9 gigahertz ITS spectrum for safety. It's for CV2X or for DSRC. And we also have 4G, 5G, Wi-Fi, Bluetooth, and even ultra-wideband-based communication. And we didn't even mention the road infrastructure with traffic lights and the traffic light controllers, cameras, and other sensors which have been in our lives for many, many years already. Now let's start with the user side. The fact that we may have 5G in our pocket and in our vehicles doesn't mean we can use this connection for everything right now. Phones are not made for saving lives by design, and not all connections work equally well in road safety. This is the fundamental question whether we can use a phone for life-saving purposes, and let's be honest, as of today, phones are not made for this purpose. There are many different phones, and the cheaper ones have much more limitations than the high-end ones. Reliability depends on many factors, such as antenna size, cellular reception, just to mention a few. Some users just don't know how to keep phones safe and secure, free of malwares. There is no guarantee that any of the available applications will run when it's needed. Users have full control of everything typically. They can block notifications, download and uninstall apps. If a user doesn't have a certain type of messenger, the messages won't arrive. V2X could possibly be only one of these apps. The phone is in flight mode. Good luck with your safety messages. New vehicles have connectivity and different interfaces to receive alerts. We work with automotive OEMs too, and having 5G in a car doesn't automatically mean that it's good for safety. Connectivity is mostly for entertainment, navigation, and over-the-air updates. Maybe passengers get on board Wi-Fi connection to use their own devices on the internet. Cars, however, usually have much better antennas compared to a cell phone, sometimes in a redundant configuration, offering robust connectivity. It makes cars better prepared to receive V2X safety messages. 4G or 5G is also a paid data plan. Sometimes it's paid directly by the user, or it's an option by the car maker, so the car maker pays for the connection to the mobile operator. Vehicles also need software to receive V2X messages, especially safety messages, to guarantee that a message will be received, and not all connected cars have this. It needs special hardware too to secure the architecture, avoid fake messages, store certificates that authenticate the message sender. These are planned carefully, aligned to standards and safety requirements. Compared to this, a mobile phone app is only a best effort service. No surprise then that today's cars V2X communication has been based on either DSRC in the past or CV2X, as safety on top of these technologies can really be implemented. Now let's take a look at the network side. Short-range messages are all about road safety. These are providing timely warnings with a precise location, transmitting potentially life-saving messages from vehicle A to vehicle B, and this has to be done fast. We need an ultra-reliable, low-latency communication. It must be free to use, not only because safety shouldn't be paid for, but it also allows direct connection between the cars or between vehicles and the road infrastructure. A mobile operator's network isn't built up with road safety in mind. However, as you will see, with the evolution of 5G, these aspects are considered. Moreover, the standardization is moving into this direction. The coverage can be spotty, and it's good enough for general, not latency critical applications. A certain bandwidth is enough to play videos in a car with good quality. And we also get long-range V2X messages about general weather warnings or roughly estimated warnings about potential road accidents. How actual and precise are these long-range information? I guess we have all seen base warnings about traffic jams already dissolved or a previous accident's location without traces where nothing is obstructing the traffic anymore. Please don't get me wrong. I do believe these type of communications are very, very useful, and I use these services almost every single day. What I wanted to highlight, that tricky situation can happen faster, and those are way more unpredictable than being able to deliver in time this way. Actually, we used to have this as part of our communication and even in our pitch, that today's technologies, especially self-driving cars, can be as good as around 95% of the time, which is a good ratio. But the problem with that, typically the remaining 5%, which can create very, very tough and tricky situations. So we have to be also prepared for that remaining 5%. Now let's pause for a moment, because we've experienced that market players sometimes use wrong terminologies, mixing cellular and safety technologies. V2X, however, covers both short and long-range messaging when it comes to standardized safety V2X communication and applications. Sometimes we also hear the term 5G for short-range V2X messages, but it can be misleading. More precise to use PC5 interface for short-range direct messages, also called sidelink, and the UU interface as the long-range link, also called up and down link. So if you see this table here in the picture, as you can see, short range is really focusing on the direct communication, whether it's a cellular-based solution, CV2X, PC5, or the Wi-Fi-based DSRC. And here the X stands for VI and P in the V2X three-letter word, standing for vehicle to vehicle, vehicle to infrastructure, and pedestrian communication. And the main purpose, the main application is about safety and efficiency. While long range, and for long range communication, 4G, 5G, or UU as being used, and here the X stands for the N, vehicle to the network. So this means that your phone or car or your communication equipment has to communicate with some elements of the network, whether it's a dedicated server or the cloud or an edge device. That's up to the network infrastructure. So moving on, this timeline is based on the 5G Automotive Association's roadmap and depicts the evolution of cellular-based communication technologies from both the direct PC5 and the cell tower-based UU perspectives. Here the standardization body is 3GPP, which is really a standardization body similar to IEEE or SAE and any other standardization organization. So as you can see, UU has been available for a while as part of 4G or LTE. The direct communication aspect was introduced by release 14 called LTE-PC5 or simply PC5. This operates in the 5.9 GHz similarly to DSRC. The next major evolution step is part of release 16 as called 5G PC5 or UNARP PC5 new radio PC5, which brings great features for transportation, industrial IoT, and to the V2X ecosystem. The top boxes show the cellular technologies standardized by the 3GPP. But for us, the bottom is more important as these are the solutions that can already be implemented. The 5G UU link was introduced in 3GPP release 15 almost 3 years ago, and it means that long-range UU connections can be established on new radio frequencies. It has reduced latency, it's more reliable, and have more capacity, but it's just the starting point in 5G, and further improvements are coming with the successive releases. If we started a PC5-based project now for direct communication, that could only be implemented with LTE PC5. Although Release 16 made 5G PC5 short-range link available in 2020, it usually takes a couple of years to implement the standard once it's completed. So car makers are still working with LTE PC5 for short-range communication as the PC5 link. And unfortunately, the COVID-19 situation also delayed the standardization and implementation process. So let's see what do we have now. As we saw it on the timeline, the LTE or 4G based UU long-range messaging was available since 2015, while short-range LTE PC5 was introduced around or in 2017. These two are in the CV2X toolbox now, ready to use. Now let's spend a little bit of time on this sample city and check the different type of communications. So first, the short-range messages depicted by the orange dashed lines. These are typically for vehicle-to-vehicle, vehicle-to-the-infrastructure communication, realizing safety-critical and also efficiency-related communications. So this is typically the PC5 direct link. While the long-range messages depicted by the red dashed lines are kind of the backhaul or vehicle to the network or X to the network communication. And as you can see, these cars are connecting to a cell tower. So this is very, very familiar and almost the same as your phone connecting to a cell tower and using its data plan. Also very important, sensor integrations to local information hubs, such as roadside units. This way we can involve the non-connected moving objects into the connected vehicle ecosystem. The most promising directions are the vulnerable road user protection use cases to save the lives of pedestrians, cyclists, e-scooters, and so on. And in this picture, as you can see, here you have a cyclist which is detected by a camera, for example, and if that is an integrated solution with an active information hub, such as a roadside unit, you can basically broadcast that information on behalf of that cyclist to this car in this example. And typically this is done with short-range messages because that can be also safety critical. So 5G UU is also coming up, and as the long-range UU connection in automotive is using the normal cellular infrastructure, this is getting more and more into the picture. But this is almost the same what we can use for Netflix and social networks. It's not like short-range messages are always better than the long-range ones. These two complement each other. Each one is good for different purposes. A long-range message can help us make early decisions, far-away events, so we can avoid more distant traffic jams, prepare in mind for a far situation, potentially dangerous. Short-range messages is more precise, contains more accurate and timely data for decision-making in immediate or soon-to-be happening situations. Cloud has a role in collecting and distributing relatively slowly changing information, such as weather and traffic updates. Some traffic and navigation services collect information cars and send that information back to its own subscribers or users. It can be done easily with long-range 4G or 5G connections. But as you can see on this slide, it's also possible to aggregate data on the roadside unit by collecting short-range messages. You may have a wired backhaul connection as well in the roadside units, or that can be also a wireless one. But if you have a 5G coverage, you can optimize your roadside unit with a 5G module and have a more reliable wireless backhaul connection. A clear benefit is that you can connect roadside units to the cloud or your central management location in order to manage and update these units remotely. This can be very handful where fiber upgrades or the wired infrastructure is problematic to be extended, but the cellular coverage is still available. So this setup can dramatically reduce the installation time required for the live operation of a roadside unit, for example. The aggregated information runs on the same network as the long-range messages. Think of it is a 5G connection in your laptop or notebook, which can be used to download Windows updates. But in this case, you can provide a direct access or 5G access to the roadside unit from the roadside units to other road users. Now let's pause for another second and let's check what we can do with the technology available. So we have seen what we can do with the technology as of today, and now let's take a look into the future. So what's ahead of us? Just to recap, release 16 already made UNR or new radio frequencies available for direct PCI communications. But don't forget, it takes around, 3 years to implement technologies defined in a cellular standard, maybe less. Release 17 coming in 2022, and it will further enhance 5G PC5 with a scope of ultra reliable, low latency communication applications, improved reliability, and reduced device energy consumption. Based on this enhancement, reliable and low latency 5G messaging may be available in 4 or 5 years from now, probably in 2025 or 2026. So it won't solve today's road safety problems. Fortunately, though, as we saw, there are techs available today to start or continue the work we have started. We also have to count with technological limitations. You may be familiar with the millimeter wave bands used by mobile operators. Your 5G phone probably using it, and it's good for multimedia in a dense city. Car makers, however, may not use it for safety because higher frequencies have significant propagation loss outdoors, and the signal can be lost. Although they experiment with this, and we do believe it has a great potential sharing raw sensor data among cars and between cars and the infrastructure. Also, millimeter wave needs base stations every few hundred yards to provide decent coverage, which may increase installation costs. But there is a good opportunity here with the existing roadside units, just to give you an example, used today in order to help to improve this coverage. So roadside units may host 5G equipment and not only being part of the communication ecosystem as a client, but also they can extend the network itself. Another interesting saying is that some in the industry say we can use 5G for everything, and under the 5G umbrella, of course, that can be true, as you saw that there are short range, long range, and then different kind of communication features and solutions. But the 5G in your phone most probably is not designed for safety critical and short range messaging. So ultra reliable low latency, which is needed for real-time safety applications, requires a dense network, and the distance between the vehicles and the infrastructure must be short. Even with a dense 5G network, cars will use PC5-like communication, either LTPC5 or U-Radio PC5 messages for quick direct communication. And roadside units will use this too, and cities will have to rely on camera and other sensor-based pedestrian and other vulnerable road user recognition. Still, cell phones are not very reliable, at least as of today. Automakers are excited about cloud solutions along with others. They collect data that expires relatively quickly, such as traffic information, and send this data back to the road users as a possible hazard alert. It's not a very precise and sometimes not even accurate information when we get very precise. As when we get to the scene, as I told the base example, maybe the traffic jam is not even there by the time we arrive to the location. It's better to use this method in case the driver doesn't have to react quickly. On the other hand, there are the direct and real-time communication ways, such as the V2V, V2I, PC5. Here we can achieve and leverage the fast and relatively accurate information. However, these deployments are not widespread yet. Therefore, a healthy combination of these communication types and methods can balance each other. Cloud information still can be very useful. It can be combined with other data sources. It helps vehicles validate information. The onboard V2X unit can put together the pieces of the puzzle. When we have multiple sources of the information, it is the obvious choice to merge or fuse these together. Typically, the more information we have, the better decision we can make, or our vehicle can make. This is also a good way to utilize 4G, 5G, and short-range messages now. Ultimately, we can gather similar information from multiple sources. Just to give you an example, road hazard warnings can come from a direct V2I link from a roadside unit, and from a navigation service like Waze, TomTom, Google Maps via V2N type of communication. The difference may be the reliability and the resolution of the information. Every single service and information type has its own benefits and drawbacks. Our picture about the surrounding world is getting better and better with more and more information and communication sources. We have to fuse this wisely and in a smart way. As you can see, the different types of sources are contributing to our vehicle's understanding and the world around it. Plus, with the overlapping information, the information accuracy and quality can be optimized. It can be more accurate and relevant for a given situation. We should not forget local sensors in the car either. these are great inputs too, and self-contained. Therefore, an ego vehicle can only rely on these without anything else from other cars or from the infrastructure. The problem, though, that just based on the local sensors, our vehicle won't be able to see everything in every single case. So it won't be prepared for any unpredictable situation. Just think of seeing through other cars, trees, or obstacles, or looking into the intersection, and so on. So connectivity is really an essential fundamentum for cooperative driving and cooperative transportation. To sum it up quickly, we have many different terminologies. However, all the three-letter words and communication technologies are focusing on saving lives and creating a more efficient transportation. As of today, an ultimate all-in-one technology is not available, but PC5 or CV2X is here. Also 4G and 5G are reality for UU and V2N communication. As we saw, the new improvement and upgrades are in the corner for both short-range and long-range communication. The ultimate goal is to fuse and merge these together to get a better understanding of our vehicles, cities, highways surrounding in order to make better decisions. With that, I would like to thank you for your attention and turn this presentation into a discussion or to the Q&A. So should you have any questions, please do not hesitate to ask those. Thank you so much. All right. I see a few questions here. And right. So the first one is, what is the definition of UU? And maybe it's a shame, but actually I don't know exactly what's that. So we will have to look into that, how to resolve that abbreviation. All right, I can see questions coming in both in the chat and also in the Q&A. Yeah, slides will be available if I'm not mistaken, and then also alongside with the recording of this presentation. All right. So here is a technical one. How good the GPS location accuracy in this hybrid solution? So that's a tricky one, because just the GPS location based on GNSS, obviously we know the limitations. With other sources and with the promise of 5G and cellular-based localization techniques, hopefully that can be improved, with which we can achieve the certain accuracy, even for self-driving cars. All right, where is the largest deployment of V2I? That again depends. If you are referring to DSRC or CV2X based ones, definitely happening in the States. There are quite extensive deployment happening in Florida, also in Colorado, and in Las Vegas, Nevada. So these are the ones, and obviously the locations of the CV pilots are great deployments in Ohio, in Tampa, Florida, in New York, also in Wyoming. But these are just the tip of the iceberg, and we see more and more actual deployments and not pilots anymore. And I hope I answered your question. All right, here is one. Please discuss your worldwide deployment. Well, since this is an anonymous attendee, I'd like to ask you to reach out to us offline as well. But we have great deployments all around the globe, not only in the States, but in different countries in Europe and also in Asia. So please reach out to us, and then because we can discuss those in detail. So here is another. Why can't we support V2N using 3GPP release 14? So maybe there is a misunderstanding here, because yes, we can use V2N as part of release 14. And as a matter of fact, even earlier, if, as you can imagine, a 3G connection that was also realizing V2N kind of communication vehicle or device to the network. So hopefully this answers that question. All right, so is there currently a deployment of integrated V2I, V2V, and V2N? Well, that's a great question, and the answer is yes, of course. And this can be as simple as cellular-based or 4G-based backhaul system from the roadside units to the central. So this is the simplest example, and that way, of course, you can have these hybrid solution, but also what we did with a navigation service provider, we fused together the V2N data coming from the cloud service with the V2X direct communications coming from other vehicles, and also the V2I information. So this can be as simple as showing, road condition warnings coming from the cloud, and improving that with the real-time data coming from a roadside unit. Please talk about your business model with your customer. That's again a great question, and I think we should take that offline. But generally speaking, in the V2X space, obviously these devices are not free, but the purpose here is to save lives and make an efficient transportation. And obviously, we try to provide a full solution, including retrofitted onboard units, roadside units, central components, and any essential building blocks. But I would be more than happy to elaborate on that business model offline. So please do reach out to me or to my colleagues, and we can discuss it. All right, let me check other questions. How ready do you think is the 5G network, not only the HONORS or radio access network, to support V2N connections that today supported via V2V? Well, that's a great question, and how I can answer that is, and it was in the presentation as well, that for safety critical and especially vehicle to vehicle communication, the direct link is right now preferred by car makers and also different industry players. So when it comes to real-time communication, high reliable communication, that's a direct link, and that's not a V2N communication. Obviously, with the evolution of 5G, low latency and high reliability may come, but it's more probable. But it's only my opinion on this one, that some kind of PC5, either the today's LTPC5 or the new radio PC5, is going to be used between the cars. All right. What testing and certification does the V2X need in Europe and US now? Well, there are different and testing and certification initiatives in both regions. In the US, we have Omniair, which is great. So it started with DSRC, and now it was recently announced that now it's extended for cellular V2X communication. So both onboard units and roadside units can be certified for the CV2X part. In Europe, actually, the focus is more on the Wi-Fi based technology. At least a huge OEM started to roll out vehicles with a DSRC-like communication called the FTG5. For that, there are plug test events and the EU RED, the Radio Emission Directive kind of certification, but that's only for the radio. So what is the single roadblock for wide adoption for V2X? Again, that's a great question. So the biggest movers of this industry, I think, the automotive car makers, the OEMs. So they need to push things forward, and obviously the the legislation and rule making can give it a push. So as soon as OEMs start developing and implementing V2X in their vehicles, the infrastructure will catch up quickly. However, these things are happening in a reverse order. So now the infrastructure sides are being improved in the States, so that's a great thing. And V2X can also bring self-contained values to the cities or highways. So think of fleet vehicles and transit signal priority or emergency vehicle preemption. So you can leverage these benefits while you are preparing your city and the highways for the mass produced vehicles rolled out by automotive car makers. There is a question: being deployed for congestion in urban areas. I'm not sure whether I can answer this question or understand this question. So would you be so kind as to further clarify this question? The being deployed for congestion in urban areas. One. I don't know if we have any other questions from anyone. Well, all right then. Oh, there is another one. So may I ask you why an operator should invest now on this infrastructure? Well, that depends who is the operator. So if that's a cellular operator, obviously there are different benefits and business motivations for extending the network with more and more cell towers. But for another operator who is not a cellular one, but wants to deploy roadside units, as I mentioned before, there are many applications you can leverage right now, and of course the potential in this system is just really great for the future. Right, here is another one. What was the biggest challenge in the latest development phase? That's also a great question, and I would ask back in what development phase are you referring? If you can clarify that, I would really appreciate it. Then let's take it offline. I would be more than happy to further discuss and investigate that question. All right. I'm not sure whether we have any other questions coming in, but if not, should you have any further questions, please do not hesitate to reach out to me or to Commsignia, because we are here to answer those questions anytime.
I'd like to thank our presenters today, Laszlo with Commsignia, for this great presentation. Again, the recording and slides will be available on the website today or tomorrow. If you have follow-up, please feel free to reach out to Commsignia or ITS America, and we're happy to connect you. And we look forward to seeing you at our next member webinars. So thank you for joining today.
Yeah, and thank you so much for the opportunity.
Thank you.
Thank you.